Hi guys, Mr. Bennett here. Today we're going to be looking at momentum and we've already done a lesson on it in class with that. So I'll just review what we did. So remember momentum is given the symbol P and it's equal to the mass times by the velocity. Alright, so the units that you can use, the shortcut units are things called sec newtons, or if you want to, what you can do is you can say mass is measured in kilograms, velocity is measured in meters per second, and so therefore you could say that is the units for momentum. We did look at two examples in class, so if we just have a quick look at those. So we had a truck and a car coming through, right, and we had the before and the after situation. So if you look at over here, we had to work out, the first step was to work out the velocity of the car to be in meters per second, and also the truck to be in there. And what we said was the initial momentum of the system was equal to the momentum of the car and then the momentum of the truck. So it worked out to be about 22,000 sec newtons for the car and about 78,000 sec newtons for the truck. So the total initial momentum of these two things, now because they're going in different directions, when you add the two vectors together, I remember going tail, head, then the initial momentum was the addition of both of those, so that gives you a vector of about 55,000 going to the left. Alright, and then we use the concept of momentum to say, well, after the collision, both the truck and the car are going to have combined mass of 4,800 kilograms. Alright, and so therefore we know that the initial momentum of the system should be equal to the final momentum of the system. So this answer we got for the first part over here basically should give you that value, and then we know that the mass over here is equal to 4,800, and the thing that we wanted to find in this situation here was the velocity of the car and the truck afterwards. So if you divide that value by that value, right, then you'll get a velocity of 11.57 meters per second or 41.65 kilometers per hour. So coming to the next bit, you can also do this mathematically. The way we do this mathematically is because the truck going to the left has a speed of negative 19, right? So when you do the mathematics, that will give you a value, and then you do the same thing before. We also did a very quick example of a bomb exploding. We said that before the bomb obviously takes off, it's because it's stationary or explodes, it's got a zero momentum. Okay, nothing's moving, zero velocity, zero momentum. And then what we said was we had these particles going off at a different direction. Right, so particle number 1, 2, and 3. I gave the information about the momentum for that and for particle number 2, so we could work that out. So momentum particle number 1 goes up this direction here at 2,000 sec newtons, goes this way here at 1,500 sec newtons. We know the mass of particle number 3, but we don't know its velocity. But if we use Pythagoras and the concept of conservation momentum, we know that the initial momentum has to be equal to the final momentum, which has to be equal to 0 in this particular case. So therefore, if we use Pythagoras, because we know these going off at right angles, we could work out what the momentum of particle number 3 was, and that worked out to be 2,500 sec newtons. Then if we know the velocity, or the mass of it, which is that, divide the momentum by the mass, and we get the volume or velocity of the actual third fragment of the bomb to be 5,000 meters per second. Right, today we just want to go through a couple of examples for you. So if we did this example over here, alright, so we've got this example here, so we've got our truck, which is 4,000, we've got our car. Now the truck's stationary, so what we've got here is the car going in and hitting a stationary truck. So if this has got zero velocity, we know the truck has zero momentum. So the momentum of the car and the truck combined initially will be only that of the car. So P of the car, that's going to be simply the mass, 800 times by 27.78. So I can go to my calculator and do that. 800 times 27.78. That gives me 22224. Alright, so we knew before, we already knew that. So the momentum is equal to 22,224 sec newtons. So in other words, my initial momentum, Pi, is equal to momentum of the car plus momentum of the truck, and so that's going to be equal to 22,224 sec newtons. Now what we know is by conservation, I have to state this, by conservation of momentum, that Pi has to be equal to P final. Now obviously in reality it's not, because in collisions we have energy losses with things like sound and heat and crumpling and all that sort of stuff. Alright, so but in an ideal world, and that's what we want to deal with in physics, alright, we know that these two things are going to be equal. So therefore, again goes back to the P final is going to be equal to the mass of the truck and the car times by the velocity of the truck and the car. Remember, we have to use these subscripts to help us understand what we're doing. So now I can put in the things that I do know. We know that's 22,204. Alright, and then we know that this over here is going to be 4,800, and that's times by the velocity of the truck plus the car. So therefore, the velocity of the truck plus the car is going to be equal to 22,224 divided by 4,800. Now on my calculator I've already got that answer, so all I have to do is now go divided by 4,800, and that will give me my answer of 4.63, and if I times that by 3.6, that will tell me kilometres per hour. Okay, so if I go back to that, so that's 4.63 metres per second, which is approximately equal to 16 kilometres per hour. Okay, so we go through that process. Now, the one that you'll get in your test, and I'm expecting you to do, will be something like that, where you've got something going in the same direction. Now, example number 2 today is looking at a car. Two cars. We've got a blue car and a red car, and they've got different masses and they've got different speeds. Now, I've already done the calculation for changing that to metres per second, because you need to be working in SI units. Right, so I think if we think of the vectors, now you don't have to do it vectorially, I'm going to do it mathematically today for you. So I'm going to say here, and this is probably good setting out, the initial momentum is equal to the momentum of the red car plus the momentum of the blue car, isn't it? Alright, so if we think about that, the momentum of the red car is equal to the mass, which is 800, times by 27.78, plus the blue car, which is going to be 1200, times by 25. So that's what I can do on my calculator. So it's going to be 800 times by 27.78 plus 1200 times by 25, and that will give me my initial momentum, which is 52,224. 52,224 sec newtons. Okay, what do we know about our situation over here? Well, we know that afterwards our Pi has to be equal to our P final. So what are these cars doing? They're going to have a rear end collision, and then they're going to go off at a combined speed. Okay, so we know that our P final is going to be the mass of the red plus the blue times by the velocity of the red plus the blue. Right, so in this particular case we know that this is 52,224. We know this is going to be 2,000, and that's our velocity of the red plus the blue. So therefore we're going to simply divide that by that. So if I go back to my calculator, divide that by 2,000, and that will give me a speed of 26.11. So velocity of red plus blue is equal to 26.11 meters per second. That's what it is. And if I want to times that by 3.6 equals 94 kilometers per hour. So if you were involved in that collision, it'd be quite a fast collision, wouldn't it? So that would represent, you know, a rear end collision. I can't quite remember the last bit. It's straight on 94 kilometers per hour. Okay, so that's kilometers per hour there. So these cars are moving, so therefore the collision means, you know, you're going to be continuing to move off at quite a speed. Because they're going in the same direction, it probably wouldn't be such a dangerous collision as if it was a head-on collision. Now remembering what we're doing here, if we've got a car going to the right, what we say is we have a positive velocity. If we have a car going that direction there, we have a negative velocity, if we want to do it mathematically. In this case, both of them are moving to the right. Let's do another example. This is another example of something that you may recognise. If you've all played 8-ball or pool, you have this situation where you fire the white ball at the red ball, and then what might happen is the red ball might go off at a speed and the white ball might be stationary, or you can even do things like put spin on the ball and it comes backwards. But we're saying there's no spin here, and what you've done is you hit the red ball and the white ball goes off at a certain speed and the red ball goes off at a certain speed. Alright, so we want to find, in this question here, we want to find what speed does the white ball go off at. Obviously it's a straight collision there. So again, the red ball is stationary, so it's got no momentum. The momentum of this system here, right, initial momentum is going to be the momentum of the white ball plus the momentum of the red ball, but we know this is in fact equal to 0. So really it's just the momentum of the white ball. So that's simply going to be mass. Actually, I don't need to write that in. We know what momentum is. So what's the mass of the red ball, of the white ball? Well, it's got 40 grams. Now 40 grams is equal to, have to divide that by 1,000 to get that to kilograms. So that's going to be 0.04, isn't it? Times that by 1,000. Yeah. So that's going to be 0.04 kilograms. So therefore my momentum of here is going to be 0.04 times by my velocity, which is going to be 10 meters per second. So that's going to mean that my initial momentum is going to be 0.4 sec newtons. Okay, and it's to the right. Now remember, this is a vector quantity, so therefore I should give a direction, and I didn't do that with the previous examples, which is wrong. I should have done that. Now, we need to say by conservation, you need to say that it's part of the question of momentum. I hope you can write better than I can. Pi is equal to P final. So therefore, we know that our final momentum, P final, has to be equal to 0.4 sec newtons. Now, Our final momentum in this particular case is equal to the momentum of the white ball plus the momentum of the red ball. Now, both these balls have got the same mass, so therefore what I'm going to do in this case is just work that out. So we know this is 0.4 sec newtons. We know this is 0.04 times by the velocity of the white ball, and that's going to be 0.404 times by the velocity of the red ball, which is 8, isn't it? So 0.4 is equal to 0.04 W. Now that times by 0.04 is going to give me 0.32. Right, so therefore I'm going to bring that across, so that's going to give me 0.4 take away 0.32 is going to be equal to 0.04 VW, and so therefore that's going to give me 0.08, and then I have to divide that by 0.04, and that will give me my velocity. So when I divide that by 0.04, that's going to give me a value of 2. So therefore, the velocity of my white ball has to be equal to 2 meters per second. And I was suspecting I was going to get that result anyway, because the only thing that's really changing here is, in fact, the velocity. So if it goes from 10 meters per second to 8, then I was thinking that this thing over here had to be 2 meters per second for conservation of momentum. In this particular case, we would say that the momentum is directly proportional to the velocity, because the mass is actually not changing in this particular case. And that's a really important language thing that you need to start working with here. Right, the mass is constant, so we would say that the momentum is directly proportional to the velocity. Now, in terms of what I'm expecting you to do, I'm expecting you to do any of these things here with objects moving in a straight line. So it could be stationary and one moving, they could be both moving in opposite directions to each other, or they could be moving in the same direction as each other. But, you know, going through, I've done, obviously there's 4 examples we've got there to look at. So the key steps are for doing these is working out the initial momentum, which is the addition of the 2 objects. The second step is to make sure that you're using the conservation law of momentum. And the third step is to actually find the unknown by using the formula there. Have a go at these questions. If you have some trouble, make sure you catch up with me in class.